Today we're going to talk about mean absolute deviation. Right, our objective will be to be able to calculate and interpret the mean absolute deviation of a data set. Right, so it's a new concept for you all. So we'll talk about what it means, kind of what it's used for, and then we'll show you how to do it. All right, so mean absolute deviation is the average distance of all data values from the mean of the set. Now that's a mouthful of words, a ton of vocabulary in that one in that one sentence, right? You have average in there, mean of the data set. All right, so let me break this down. All right, so what is mean absolute deviation? What does it mean, like in a working sense? We'll talk about that first. So I have an example here of two students. I have student A and student B, and these are student A's grades and student B's grades. And if you look at their grades, right, you see here at the bottom I have their average, right? They have very different looking grades, but they both have an average of 60, right? And so if you were just somebody looking at two students' grades, you would just say, okay, well, there's two kids there that have a 60. But there's deeper information in the numbers than just their average is 60, right? For me as a teacher, I can't just look at the average. I need to look at the whole body of work, right? And so some of that is kind of like mean deviation, and I'll show you what I mean by that. So I'm looking at student A, right? They have 100, a 95, an 85, an 80, but then they have two zeros right here. And so for me, looking at student A, I think if I can just get student A to turn in all their work, I think they'll be doing fine, because everything they turn in is a good grade. So if I can get this fixed, right, the zeros fixed, then their average would be way higher, and that'll be, I think they'll be okay. For student B, there's a little bit different situation. Student B's turned everything in, but their grades aren't where they need to be. And so for student B, there's a different approach. I don't just need them to turn work in because they're already doing that. I may need to get more one-on-one time with them. I may need to ask them to come to tutoring. We may need to look over some turned in work and address some issues that may be happening over and over again, right? There'll be different methods. And so looking at the overall body of work, I would see that student B is in a different situation than student A, even though their averages are the same, right? And so where does mean deviation come into play with all that? Well, mean deviation is essentially like the average is a 60, and all the numbers here are very far away from 60, so you have a big mean absolute deviation, right? The distance that each of these data points is, like the distance that all these grades are from the average, is high, right? Because their average is 60, but they got zeros, they got hundreds, they got 95s, right? All their numbers are so far apart from their average, and so that would tell me that this student's grades aren't very consistent, right? If I look at student B, their mean absolute deviation is only 5.33. It's very low. And so then what that tells me is all of their grades are real close to a 60, right? You got a 66, a 59, an actual 60, 55, 70, 50, right? None of their grades are too far away from what their average is. And so like the lower the mean absolute deviation number is, that means the closer the grouping of your data set. Right, the closer these numbers are going to be. If you have numbers all over the place, a very high number, a very low number, then that mean absolute deviation is going to be a lot bigger, because all these numbers are so far apart from each other and from the average. All right, so that's in a nutshell kind of what mean deviation is. And so how did I come up with these numbers? Where did 40 and 5.33 come from? That is mean deviation, right? Mean absolute deviation. So let's talk about how to do that. So steps wise, you're going to want to find the mean of the data set, which mean is another word for average, right? So we'll find the average of the data set, which we did that in DIY 1, finding the average. And then after you find that average, you're going to get the absolute value of each data point from the average or from the mean. Alright, so you're going to just get the difference, see how far away every data point is from the average. And then after that, you would find the mean of those distances. So it's really just 3 steps. We're going to use this little acronym ADD/SAD to help us remember what to do. A meaning add, addition, right? D meaning divide. After you add and divide, which would be step 1, that number would go here in the parentheses, right? And then you would use that number in the parentheses to finish off the SAD, right? SAD meaning you would subtract. That's the S. A meaning add. And D, right? So divide. So they're all operations. You're going to add, divide, come to a number, then subtract, add, divide, right? So nothing is, outrageous. You've been adding and dividing and subtracting since forever. Alright, so find the mean absolute deviation of the data set, right? So I'm going to refer to ADD/SAD so you can see how it works. So the first thing I need to do is add all of the numbers in my data set. So I'm going to add all these numbers up. Alright, so we have 58 plus 88 plus 40 plus 60 plus 72 plus 66 plus 80 plus 48. Right? So add all that up and you get 512. So that's the A, add. D is divide. So when I added that up, I got 512. And then I'm going to divide. You divide by how many numbers you had total. And so total here, there were 8 different numbers. And so I'm going to divide 512 by 8. And again, you can use your calculator on your phone. You can use Desmos.com. All right, if you use Desmos, just go to the scientific calculator, and then you can do that. Desmos also has an app, and for Apple and for Android, so you can download that in your like your app store in Desmos, and then you'll have a calculator on your phone. I can get back. All right, so then we divide by 8, so we get 64. So we write that number in the middle, right? So we added all these numbers up, divided by the amount of numbers there were 8, so we divided by 8 and we got 64. Now we're going to use this number 64 to subtract. And so the step 2 in this is to see how far away each data point is from the mean, right? From the average. So the average is 64. So how far is each of these numbers away from 64? And so really I'm just going to set up a bunch of subtraction problems. I'm going to write all these numbers out. Running out of room. Right, and I'm going to subtract each of these numbers. All right, I'm going to write minus 64 on all of these. Right, how far is each number away from 64? So I'm just getting the difference. Okay, and then you just do that subtraction. And this is the part where we take the absolute value. So if you remember absolute value from DIY 1, right, the absolute value of a number is always going to be positive because you just want how far is that number away, how far is one number away from the other number, right? So how far is 58 from 64? Excuse me. So you could go to your calculator, right, and do 58 minus 64. And if you do, again, you're going to take the absolute value of this number, so it's just 6. It's 6 away. Alright, and then you just do the same thing with all the numbers. 88 minus 64 is 24. 40 minus 64 would be negative 24, but the distance away, right, the absolute value is 24. Here is 4 away. How far is 72 from 64 is 8. So again, this is the subtract stage. 66 minus 64 is 2. 80 minus 64, 16. And 48 minus 64, I think it's 16. Yeah. So again, I'm taking the absolute value here, so it doesn't matter if that's a negative 16. I want to know how far is 48 from 64, which is 16. Right? Then you add up all these numbers, right? So pretty much I'm just going to get the average of these. So I'm going to add up all these numbers and then divide by 8. So let's add those up. Got 6 plus 24 plus 24 plus 4 plus 8 plus 2 plus 16 plus 16. Right, add that up, you get 100. And then to finish it off, the last step, you added, and now you divide by 8, right? You're getting the average of that. What? And you get 12.5. So the mean absolute deviation is 12.5. Right, so the problem takes a little while to do, you know, just a few minutes, but it's nothing that you can't do. We were just, you saw, we're adding, multiplying, or not even multiplying, we're adding, dividing, subtracting. That's it. So just use this add sat to keep you in order of what to do, and you'll be fine. Let's do another one. All right, so here we have less numbers, so it'll go quicker. But to find the mean absolute deviation, again, I'm going to go through A. I'm going to add up all the numbers. So 78 plus 45. +48 plus 45 plus 60 plus 33 plus 84. Alright, when you add that up, you get 300. You have 5 numbers here, and so now you're going to divide. I'll go ahead and do some long division. How about that? 60. So 60 is the average and so now you subtract. Right, I'm going to subtract each of these numbers by 60. So 78 minus 60, 45 minus 60, 60 minus 60, 33 minus 60, and 84 minus 60. Right, and so now I'm going to do this subtraction. Again, taking the absolute value of the answer here, no matter if it's positive or negative when you do that subtraction. 78 minus 60 is 18. 45 minus 60 would actually be negative 15, but you just take the absolute value, so 15. 60 minus 60 is 0. 33 minus 60 would be negative 27, but you take the absolute value, so it's 27. Making sure. 84 minus 60 would be 24. Alright, and so now we've done the subtraction. Now we add, so we're going to add all these numbers up. Now I can't see them. 18 plus 15 plus 27 plus 24. Right, you don't need to type in add plus 0 because it's going to be the same thing. Even though 0 is there, you still divide by 5 on the next step. Right? Don't think that because that's 0 it doesn't count. 0 is still a number, it just doesn't have a value, a numerical value. So you're still going to divide by 5. But after you add those numbers up, you get 84. And then the last thing will be to divide, so you would do 84 divided by 5. So you're 16.8. So your mean absolute deviation is 16.8. Alright, I'll do one more. These are small numbers, so it should go pretty quick. Again, add up the numbers. So I'm going to add them all up. Got 3 plus 1. Let's see. Let's go old school. Got 4 here. 9. 14. 23. Alright, so I got 27 here. Right, add them all up, then divide. Divide by how many numbers there are. There are 6 numbers, so 27 divided by 6. I think that's 4.5. Right, 4.5. Okay, so 4.5 is your number here. So now I'm going to use this number to do the next step, which is subtraction. Right, I'm going to subtract 4.5 from all these numbers. Alright, and so when you do this subtraction, again taking the absolute value of your answer. So I'm just going to write the absolute value of it, even though the answer, when you do 3 minus 4.5, you're going to get negative 1.5, but the absolute value of that is 1.5. Right, this is going to be 3.5, 1.5, 2.5 3.5, I think. Pretty sure. And then 2.5. Okay, so now you did your subtraction. The next step is to add. So you're going to just add all these numbers up. .5 plus 3.5 plus 1.5 plus 0.5 plus 3.5 plus 2.5. Right? Add them all up, you get 13. And then you would do 13 divided by the amount of numbers there are, which is 5. That's your division, your last step. So 13 divided by 5 is 2.6. So the mean absolute deviation equals 2.6. All right. The next is a U-try for you to do, and here are your numbers. If you want to go ahead and pause the video and then restart it after you try it, I'll uncover the answer. That way you'll know if your U-try is correct or not. So here's the answer. The mean absolute deviation for this set is 13. Let us know if you have any questions. Show up to tutoring, ask those questions, come to the lives. See y'all soon.